Ever wondered about the marvels we can uncover in the vast reaches of the universe? Picture a telescope so advanced that it peers back billions of years to witness the birth of galaxies. This isn't a tale from science fiction, it's the reality of the James Webb Space Telescope, launched in 2021 as the pinnacle of space observatories. JWST is reshaping our cosmic understanding by revealing the intricate details of exoplanets and capturing the awe-inspiring spectacle of star formation in unprecedented clarity. Its groundbreaking discoveries are rewriting what we thought possible, pushing the boundaries of astronomical exploration. Join us as we delve into how JWST is unlocking the secrets of our universe, heralding a new era of discovery and understanding. The James Webb Space Telescope stands as a testament to human innovation, featuring a 6.5-meter primary mirror made of 18 hexagonal segments of beryllium, each coated with a thin layer of gold. This design allows the mirror to fold for launch and unfurl in space, maximizing its infrared light-gathering capability. The gold coating enhances its reflectivity for studying distant galaxies, stars, and planetary systems. JWST's sunshield, spanning the size of a tennis court, is crucial. Composed of 5 layers of Kapton coated with aluminum and silicon, it shields the telescope from heat and sunlight, keeping its instruments chilled to 233 degrees Celsius. This extreme cold is essential for its infrared observations, enabling detailed studies of cosmic phenomena. Equipped with advanced instruments like NIRCam, NIRSpec, MIRI, and FGS-NIRIS, JWST enables groundbreaking research. It captures detailed images of distant galaxies, studies star formation, and analyzes exoplanet atmospheres for potential signs of habitability. Positioned at the L2 Lagrange point, JWST operates away from Earth's interference, ensuring clear observations that push the boundaries of astronomical discovery. The James Webb Space Telescope stands as a marvel of modern astronomical engineering, revolutionizing our understanding of galaxy formation and evolution. With its 6.5-meter primary mirror and advanced infrared capabilities, JWST peers back in time to capture light from galaxies that formed only a few 100 million years after the Big Bang. This ability provides a unique window into the early universe, where galaxies were in their infancy and fundamental structures like stars and black holes were just beginning to take shape. JWST's observations challenge and refine existing models of galaxy formation. By studying these ancient galaxies, astronomers can piece together the timeline of cosmic evolution, from the primordial soup of hydrogen and helium to the complex cosmic web of stars and galaxies we see today. The telescope's infrared sensitivity is crucial for these studies, as it allows astronomers to penetrate cosmic dust and observe the faint infrared emissions that reveal the stellar populations and dynamics of distant galaxies. One of JWST's most groundbreaking achievements is its capability to detect and study the first light of the universe. This refers to the era known as reionization, a period when the universe emerged from its dark ages as the first stars and galaxies formed and began emitting light. JWST's ability to observe these ancient galaxies provides critical insights into the processes that drove reionization, shedding light on how the universe transitioned from a neutral gas-filled state to one dominated by ionized plasma. The telescope's observations have already yielded fascinating results, such as identifying galaxies that existed when the universe was only a few 100 million years old. These findings challenge previous theories and offer new insights into the early stages of galaxy formation. They also provide clues about the conditions under which the first stars and galaxies formed and the role they played in shaping the universe we observe today. Beyond its scientific discoveries, JWST serves as a beacon for the future of space exploration. Its advanced technologies and unprecedented capabilities set a new standard for astronomical observation. The data and insights JWST provides are not only expanding our knowledge of the cosmos, but also inspiring future missions and endeavors. By studying the origins and evolution of galaxies, JWST contributes to our understanding of fundamental astrophysical processes and the conditions necessary for planetary formation and potential habitability. Looking ahead, JWST's discoveries will continue to inform and shape future space missions. The insights gained from studying distant galaxies and the early universe will guide the planning and execution of upcoming missions aimed at exploring our solar system, searching for exoplanets, and probing the mysteries of dark matter and dark energy. JWST's legacy will extend far beyond its technological achievements, paving the way for humanity's continued exploration of the cosmos and our place within it. For instance, JWST's detailed observations of exoplanet atmospheres will help refine the targets for missions such as the European Space Agency's Ariel, Atmospheric Remote Sensing Infrared Exoplanet Large Survey, and NASA's Habitable Exoplanet Observatory, HABEX. These missions aim to characterize the atmospheres of exoplanets in detail, searching for signs of habitability and even potential biosignatures. By identifying the most promising candidates, JWST is laying the groundwork for the next generation of exoplanet explorers. Moreover, JWST's ability to peer into the early universe and observe the formation of the first galaxies and stars provides critical insights that will inform the design and objectives of future space telescopes. The proposed LUVOIR, Large UV Optical IR Surveyor, and Origin Space Telescope, for example, will build on JWST's discoveries to explore even more distant and faint objects, pushing the boundaries of our cosmic knowledge. In the realm of planetary science, JWST's observations of our own solar system, including the outer planets, their moons, and distant objects in the Kuiper Belt, will guide future missions aimed at detailed exploration. Missions like NASA's Europa Clipper and the proposed Ice Giants mission to Uranus and Neptune will benefit from JWST's findings, which will help determine the best instruments and strategies for studying these enigmatic worlds. Furthermore, JWST's unprecedented data on cosmic phenomena, such as dark matter and dark energy, will drive theoretical and experimental advancements in physics. Understanding these mysterious components of the universe is crucial for developing a comprehensive picture of cosmic evolution and the fundamental laws governing it. Thanks for joining us on this cosmic journey with the James Webb Space Telescope. If you're as fascinated by the wonders of the universe as we are, hit that subscribe button and ring the bell so you never miss out on our latest space discoveries. What mysteries of the cosmos do you want JWST to uncover next? Share your thoughts in the comments below. And remember, the universe is vast. Let's explore it together. See you in the next video. And until then, keep exploring and dreaming big.